November 1st, right? Yes, what am I doing?
So 498, number 81.
498, number 81?
Yeah.
Okay, let's see what it says. 498. 498. 499, 498, number 81. Okay, so
Actually, you know what? Not 81, 80.
which one?
Number 80.
We did that in class, I think. We can do it again.
No, do we have to do 81? No, we're supposed to do 81 by accident for 80. That's what I said.
So we want to look at 80?
Yeah.
Okay, so 80, 1 plus sine x over 1 minus sine x minus 1 minus sine x over 1 plus sine x. They say it's 4 tangent x secant x. Good. So let's start from the left-hand side, obviously, and see if we can get the right-hand side. Okay. So the left-hand side, I find the least common denominator to be 1 minus sine x times 1 plus sine x. Because I remember you say 1 minus sine squared. So I think we did something, at least something similar.
So you don't simplify the 1 plus sine x or 1 minus sine x to cosine x?
It's 1 minus sine squared x equals cosine squared x. So remember those three identities. They have nothing to do with sine and cosine. They have sine squared, cosine squared, tangent squared, secant squared, cotangent squared, cosecant squared. Okay? So then I have to multiply this by 1 plus sine x and multiply this by 1 minus sine x. Since they are the same, I'm going to use a special product. We have an agreement on that. First term squared plus 2 times the first times the second plus the second term squared. These are the same. First term squared plus 2 times the first times the second plus the second term squared. We agree? Okay. Now minus. Keep the minus outside and leave it alone for a moment so we don't make a mistake. Now this is 1 minus sine x squared. First term squared minus 2 times the first times the second plus the second term squared. Can anyone tell us the next step? Yes, distribute first. Yes, I would recommend that. Of course, that's my target. So this is 1 plus 2 sine x plus sine squared minus 1 plus 2 sine x minus sine squared over, and you can write, remember I said normally we don't multiply the factors in the denominator, but this time I will do it. A plus b times a minus b is a squared minus b squared. And now I see at the top positive 1 with negative 1, sine squared with negative sine squared, and that's how I get the 4 sine x. Over what? What is 1 minus sine squared? Yes. And yes, I look here and I know what where I'm headed. So this is 4, this is sine x over cosine x times 1 over cosine x. Yes, here, this is what I remembered. This is what I remembered. Very similar identity. It's not that one though. Good. So now this is tangent and this is secant. So 4 tangent x times secant x, which is the right-hand side. Anything else for me? Other questions? Yes, Chris?
Could you do a number 19?
Yes, 19 from?
7.1.
Yes, number 19. 19. Yes, the 1 plus cosecant x. Is that the
Yeah.
one? Okay, very good.
Over a cosine.
Very good. So let's look at 19 on 498. 1 plus cosecant x divided by cosine x plus cotangent x. Perfect. This is not an identity. In this case, we are given an algebraic, an expression, a trigonometric expression, and we are asked to completely simplify it, right? Okay, perfect. So, any suggestions, or what did you do?
Change to 1/7.
Very good, excellent.
And then cotangent to cosine over
Yes. Good. It's a complex rational expression. I have to find the, yes, the numerator has the denominator of sine x, and this needs a sine x. It's sine x over sine x.
So it's sine x plus 1.
Yes, sine x plus 1. Now the denominator, please factor out cosine x. It's easier if you do. I'm not saying you're not going to get the same answer, but why not factoring it out and bother with it? I don't want to bother with it. So inside I have 1 plus 1 over sine x. And now I realize that if I had not performed this operation here, notice that the top and this are identical. So the simplified form is 1 over cosine x, which means what? Yes. So this is 1 over cosine x, which is secant x. Very good. It's a powerful tool to know. Knowing trigonometry will help you a lot. So this is the simplified form. Chris, is this okay?
Yeah.
Perfect. Anything else? Anyone else has anything for me? Andrew, do you have anything? Okay. Parker.
Yeah, I have one more.
Yes, please.
Number 77.
At least the section.
7.1.
Okay, very good. 77. I see it. Page 499. So cosine squared t plus tangent squared t minus 1. Everything divided by sine squared t, they say, is tangent squared t. I know it's a silly question, but I'm going to ask which side do you think I should start. I know it's silly. Yeah, I knew you were going to say that. Okay, so let's start with the left-hand side then. So we have cosine squared plus tangent squared minus 1 divided by sine squared.
Are we going to change like either sine squared or cosine squared to the opposite?
Not yet.
Okay.
Not yet. It could be. It could be. We'll see in a moment.
Since we're trying to cancel out.
Right.
So
Here's what I would like to do. The denominator, do you want to think about it for 20 seconds or you want to go ahead?
So I did the change. So I first started by changing tangent x, but I guess
It's a very good idea.
Okay.
It's a very good idea. Here's what I would like to do. For now, remember I said with these identities, sometimes I do know by simply looking at this, I will say to myself, oh, I know how to get that. At this particular instant, I can't say that. I really don't. I really don't know how I'm going to get from here. But I have to try something. I know some identities, right? I know sine squared plus cosine squared equals 1. I know 1 plus tangent squared equals, yes.
Oh, I have an idea.
Yes.
All right. So if we change cosine squared to 1 minus sine squared, wouldn't the two ones like cancel out, and then the sine squared and the sine squared cancel out, leave your tangent?
Only if you separate it.
Yeah.
That's exactly what I was trying to do. But only if you separate, you cannot simplify in the sum. We have to establish this one more time, okay? This is very important. If I have x plus 1 divided by x, doing this, it's absolutely wrong. But doing this is correct. And then you will say 1 plus 1 over x. I accept that. But simplifying a term, this is a term, not a factor. You cannot do that. Okay? Let me explain why one more time here. Because this expression is x plus 1 divided by x. So it's like saying I'm going to simplify this x with this x. Okay? That's what it really means. And that's not allowed. Okay? Good. I completely agree. This is what I was going to try to start with. I will change this into 1 minus sine squared. I will still change tangent squared into sine squared. It's t, not x, I'm sorry. Divided by cosine squared, and see what happens. And everything divided by sine squared. As you said, the positive 1 with the negative 1 will go away. Now, like I showed here, I'm going to separate into two fractions because the denominator is one term. Look here for a second. If I have this, I cannot separate it. But since I have only one term, I can separate the fraction into two fractions. Or if I have 3 terms at the top, I can separate into 3 fractions. So then I will have negative sine squared over sine squared, and then plus sine squared over cosine squared, and this is sine squared over 1 times 1 over sine squared. Let's do this one more time together. So obviously this is clear, right? Now let's see how we handle this one. This is over 1, so I copy the fraction from the top and I flip the denominator into 1 over sine squared. Are you with me? What would you recommend next? Of course, the first part is negative 1. There is no discussion there.
Yeah. So we cancel out sine.
And what is 1 over cosine squared?
Secant squared.
Exactly. Secant squared t. And we do know those 3 major identities, Pythagorean identities. What is the one that we know with secant squared? Secant squared equals
Tangent squared.
1 plus
1 plus
1 plus tangent squared. So this is negative 1 plus 1 plus tangent squared t. I don't know why I'm still writing x. I'm sorry. So this is tangent squared t, and this is exactly the right-hand side. It's not the only way. This is the route that we picked. But is it clear? Always remember that algebraic trick. If I have, one more time, if I have a plus b plus c divided by x, let's say, I can rewrite it as a over x plus b over x plus c over x. An important trick.
Well, wouldn't it be 5c over x, or would it still be plus? Oh, never mind, sorry. That was okay.
Good. Is there anything else that you have for me?
59. Oh, 7 that one.
Say it again.
59.
59. Nothing from 7.2. You didn't get to 7.2 yet. I know it's a lot of work, but it's the only way. It is.
I believe it.
That's how you're doing so well, because you do, believe me. Chris, I'm sorry, I'm talking. 59, you said?
Yeah.
Okay. That does it. And Shane is laughing at me. That's it.
Never laughing at you with me. Not nice like that.
That does it. I'll find a way to retaliate.
Yeah. That's not good company.
Leave on the screen alone.
Okay, so I do believe that the left-hand side is more involving than the right-hand side, and I hope you agree, because it has that squared at the top. So now he's cautious. He agrees with me. So the left-hand side equals. I square the top. How many terms do I write? We have an agreement. Please don't say 2.
Sine squared
Yes?
and 2 sine cosine. And
How can I be upset with him? Really?
I remember the agreement.
Yeah. Well, I hope that little bit of a game just now triggers the memory and maybe helps you in remembering that. I'm hoping. I'll do anything that helps you. So now look at the top and say, oh, I see this is what?
You can do the same thing. Split them up.
I'm looking at this, and I want you to see it right away.
Oh, that's 1 minus.
1 plus 2 sine t cosine t over sine t cosine t. Of course I will do that. What Parker just said. What is it? What am I going to do?
Put it to 1 over sine.
Yes.
Cosine
Plus,
plus 2 sine t cosine t over sine t.
which is?
Which is sine. Yeah, sine. Oh,
They go away.
okay.
Equals. Now look here. I got the 2. And I can split 1 over sine t cosine t into 1 over sine t times 1 over cosine t. And that will tell me exactly what I need to do next, which is what? What is 1 over cosine t?
Oh, it is secant.
And what is 1 over sine t?
Cosine.
So that equals the right-hand side. Anything else?
So sine and cos the 2 sines in the middle, sine and cosine, they turn to 1.
So you mean these 2?
No, the one in the middle.
This.
Yeah.
So 1 over this is here. This over this is 2.
Oh, okay. Cancel.
Is this clear? Do we have anything else? Is that a yes or a no?
I got one.
Yes?
So for simplifying the expression,
Yes?
number is 25.
Which section?
This was still, it's still 7.
Okay, 25.
Yeah.
So tangent theta plus cosine of negative theta plus tangent of negative theta.
So I ended up with the right answer, but I just want to make sure it's.
Very good. So what we know, which functions are odd, which functions are even.
Everything's odd except cosine.
Except cosine and secant, indeed. Very good. So then,
So the negative with cosine goes away, and the negative with tangent kind of goes around it.
so tangent will stay as is. And now what do I do here?
It's good way.
Yes, because cosine negative x equals cosine x. That's the property of an even function. And this one, it's odd, so it's minus tangent theta. So then the answer is cosine theta.
Oh. I did that. The wrong way.
Yeah. I broke that.
Yeah, I broke it down sine cosine.
There is no need. Remember, when you see a negative angle, your first thought is to ask yourselves, is it odd or is it even?
Yeah, I did that.
I refuse to work with negative angles.
Yeah, I know, but I did that. But when I broke it down, I was like, oh, we found this least common denominator.
No need.
See that?
No need. So I refuse to work with negative angles. So once I know that if I'm given sine negative alpha, I know it's negative sine alpha. If I'm given secant negative alpha, I know it's secant alpha, because secant is even and cosine is even and everything else is odd. Always keep that in mind. Anything else for me?
21.
Page
Same thing. The same place we're at.
21.
It's 1 plus sine u over cosine u plus cosine u over 1 plus sine.
Good. I'm adding fractions. I can't add them unless they have the same cosine u, 1 plus sine u. This one needs a 1 plus sine u. This one needs a cosine u. 1 plus sine u times 1 plus sine u. I'm using the special product. 1 plus 2 sine u plus sine squared u plus cosine squared u. If you will always use those identities that I ask you to use them, like the special products, you will be at least a month ahead of everyone else in the next class. Because everyone else who does not know them, they will struggle understanding how come a plus b squared is a squared plus 2ab plus b squared, and you will be way ahead. So, very important. Okay. Now I see sine squared plus cosine squared, which is 1. I will add the 1 in front. I think we did this problem together. So it's 2 plus 2 sine u over cosine u 1 plus sine u. And of course I will do what next? Factor out 2. And I have 1 plus sine u over cosine u and 1 plus sine u. Simplify, put 1, and this is 2 over cosine u, which means 2 multiplied by, which is, anything else? Anything else once? Twice? Done. I'm kidding. Of course, we can go back if you have questions. Since you haven't asked anything about 7.2, let me refresh your memory on those formulas because I need them now. So we continue with 7.3. And the title is big. Double angle. Half angle. And product to sum. Product to sum. And sum to product identities. These I will give. Yes. The product to sum and the sum to product, I will not ask you to memorize them.
We have to for the next class?
Say it again.
We have to memorize it for the next class?
No. For the rest of the semester. If I put something like this on the next test or the final exam, you will be given those two formulas. They are useful. The reason why I'm not emphasizing or super emphasizing them right now is because they are not used in Calc 1, they are used in Calc 2. So it's unlikely that you will remember them in 2 semesters from now. Maybe not, but I don't want to spend time on memorizing those two. Okay, the other ones are very important. So the double angle and the half angle are super important. Okay, so at least we do halfway, and this you will be given. Okay, so let's review quickly those 3 formulas from last time. Here they are. Sine a plus b equals. You don't have to write them again if you don't want to. It's a good practice to write them again with me. Sine a cosine b plus sine b cosine a. You can use alpha and beta, you can use x and y, you can use anything you want. It's up to you. Now if we have minus here, then we have minus here. Next one, cosine A plus B. The formula is cosine A, cosine B, but minus sine A, sine B. It's important to remember that sine of the sum of two angles goes sine, cosine, but the cosine goes cosine, cosine, sine, sine. So of course, if we have minus here, then we have plus in the middle. And the last formula is that for the tangent. So tangent A plus B is tangent A plus tangent B over 1 minus the product, tangent A times tangent B. And if we have minus the difference of the angles, then it's the difference at the top and the sum in the denominator. So the top goes with what we have. The denominator is the opposite. Okay. So now our next target is this. What does the double angle formula mean? It means sine of A plus A, which is sine of twice A. This is what we mean by sine of a double angle. Sine of twice the angle. This is not sine of 2 and then times A. This is sine applied to 2A. Okay. Now, I would like you to discover this formula for us. Sine A, cosine, there is no B. Right? Sine A, cosine A plus?
Sine A plus sine A.
Good. So sine A, cosine A plus sine A, cosine A means? It means? How much is an apple plus an apple? There? Right. 2 apples. 2 sine A, cosine A. That's all I want you to say. That's it. This is the formula for the double angle. When we apply sine to it, how did I get it? From this one. Because I had sine A cosine A plus sine A cosine A, which means 2 of those. Okay, so now for cosine. Cosine A plus A, can anyone give us the formula, please? Which is, of course, cosine twice A. And tell me what you get.
Cosine A minus 2.
So you have cosine A times cosine A. How much is cosine A times cosine A?
Oh, cosine squared.
Exactly. So this is cosine squared A minus?
Sine squared A.
This is not to be confused with 1. 1 is sine squared plus cosine squared. This is specifically cosine squared minus sine squared. And this is it. You cannot simplify it. However, there are 2 more forms of it. This is the only one with 3 forms. So when we talk about cosine twice of an angle, twice the angle, then we have either cosine squared minus sine squared, or please replace cosine squared in terms of sine squared and come up with a second option.
1 minus sine squared.
And 1 minus sine squared will be 1 minus?
2 sine squared.
Exactly. So that's the second possibility. But it comes from this one when I replace cosine squared by 1 minus sine squared. Now I would like you to do the other way. I would like you to replace sine squared by 1 minus cosine squared.
So
No, because 1 minus, you have to distribute the negative. Don't jump over that step.
1 minus 2 cosine squared.
So, exactly. So negative 1. So that will be 2 cosine squared A minus 1. So why do we need this? You will see in a minute why. But one reason is I may be given sine of A and may be asked to find cosine twice A. I'm not going to find the other one. I'm going to use this formula. So if I'm given sine, I'll square it, multiply by 2, by -2, and add 1 to get that. What if I'm only given cosine A? Then I will use this form. So if I'm given cosine A equals 1/2, then I will plug it in and I will get cosine twice A. If I'm given both, I will use this formula. But if I'm given sine, I will use this. If I'm given cosine, I will use this. That's why we have 3 formulas here for cosine twice alpha, twice A. Now tangent. A plus A, which is tangent twice A, and I would like you to tell me what to write. You are plugging it in the formula, right?
Yeah, so 2 tangent.
Exactly. Over
1 minus 2 tangent.
1 minus,
2 tangent. Okay.
it's the product.
Oh, it's wrong.
When I multiply x by x, I don't get 2x.
Tangent squared.
Exactly. I'm sorry, I was starting the tangent and then I left it for some reason. I'm going to make the correction right now here. Okay. These are the double angles, identities. In case you forget, you go back to the basic ones. You can always, once we're done, we're going to practice so much that we should remember them. Okay. Now I would like to discuss these formulas from a different perspective. So please look. I'm going to copy just the first one. Now we know that sine twice the angle is 2 sine A cosine A. Now, what if I say I would like to use this formula for sine A? What will you write? Notice the pattern. Twice A, A, A. A, 2 sine. Exactly. Times cosine. Exactly. One more time. This is the double angle, and this is the angle. If this is the angle, this is the double angle. So the point I'm making here is these formulas can be used even if I don't have a double angle. What if I have this situation now? I want you to come up with sine 3A using the same formula. What would you write? The pattern hasn't changed, the same thing. You have to use the same pattern. What about this? What would you say?
3A. 2 sine 3A.
Do we understand the pattern? Okay, I will have to do the same thing with cosine. So let's try.
Are these the half angles?
The double. We haven't talked about the half angle yet. Okay, let's do one more.
2 sine A over 4.
Exactly.
Cosine A over 4.
As long as this multiplied by 2 is this, you're fine. Because this is a double angle. Okay, let's do for cosine. Let's say I want cosine A. Use any of those 3. I don't care which one you use. We have 3 formulas for cosine twice alpha, or 2A.
So cosine squared.
Exactly.
Cosine.
Minus sine squared A over 2. Okay, one more. I want to use cosine 7A. Let's see, you replace it with the one with sine.
Alright, so 1 minus 2 sine 7 over 2
Squared.
squared 7 A over 2.
Exactly.
Okay. That makes
So we can play with that as because you may see something like this. Okay, perfect. Okay, now I would like to talk about the half angle, and then we go back to the book and work on problems. Okay. So although I boxed it in, so we were all these starting from here, double angle. Okay. Now I would like to look at half angle. Ready? Okay. So let's start with cosine twice x with the formula for sine. As you said, 1 minus 2 sine squared x. Is this correct? Is this what we just had? Cosine twice the angle is 1 minus 2 sine squared of the angle. Correct? Okay, I would like to solve this equation for sine squared first. So walk me through.
Sure.
Yes? Since this is negative, it's not a mistake what you just said. It's perfect. Let's do this. 2 sine squared x equals 1 minus cosine 2x. Only because I didn't want to multiply later by -1. It's the same thing. It doesn't matter really. Okay, perfect. So now in order to solve for sine squared, what would be the final step? Yes. Super important formula. And you can say, what does this have to do with half angle? In a second you will, right here. Now this is the half angle. Please follow the pattern and tell me what to write.
1 minus cosine squared.
There is no cosine squared.
Oh, that is 2x.
Yes. 1 minus cosine. So when this is x, this is twice as much. When this is x over 2, this must be twice as much. Exactly, divided by 2. This is the half angle formula. Very, very important. This is the half angle formula for sine. And you can say, well, wait a minute, it's sine squared. Oh, okay, I'm going to take the square root from both sides and get sine. When I take the square root from both sides, I have sine x over 2, and what do I have on the other side? Mandatory. There is something I cannot forget. Exactly. Very, very important.
Use all the formulas, or use all the same formulas?
Yes, they're all the same formula, actually. I completely agree. They're all the same. Just the last one, I took the square root from both sides. And how did I get the second one from the first one? By replacing the angle x by x over 2. Therefore, 2x must be changed into x. The same thing, I would like to find the half angle for cosine. How do I start? With the same formula, but the one that has only cosine on this side. Can anyone dictate that? Cosine twice x equals, yes. Good. So now I'm solving for cosine squared x. Yes, I will add 1. Cosine 2x plus 1 equals 2 cosine squared x. And now I finally solve for cosine squared x. Can anyone tell us what to write? So cosine squared x equals? Yes, I'm going to write it because I would like it to resemble this one as 1 plus cosine 2x. It's the same thing. Cosine 2x plus 1 or 1 plus cosine 2x is the same thing. Now I would like you to give me the formula for the half angle. The cosine squared x over 2. What would you say?
Is x 1 plus cosine.
Exactly. Over 2. Of course, now we want to take the square root. So then we have cosine x over 2 equals plus or minus the square root of 1 plus cosine x over 2. I highly recommend remember these two formulas together. How, what am I referring to? I'm referring to this. Sine x over 2 is plus or minus the same thing with cosine, but plus in the middle. This one has minus in the middle, and this one has plus in the middle. Any questions so far?
So the actual formula is the cosine x over 2 equals
Yes.
plus. Okay.
Yes,
So
but you know where it's coming from,
Yeah, where it's from.
and we will have to use these.
Okay.
Yes. Good. So let's also look at tangent twice x. So which is sine twice x over cosine twice x. And maybe I should just look at the squared part. That's better. So then tangent squared, this is fine, but I really don't need it. I just want to create the ratio of sine squared x over 2, the ratio of sine squared over x over 2 over cosine squared x over 2. So this is sine squared x over 2 over cosine squared x over 2. Sine squared x over 2 is 1 minus cosine x divided by 2. And sine squared and cosine squared x over 2 is 1 plus cosine x divided by 2. After I flip and simplify, I get 1 minus cosine x over 1 plus cosine x.
That's the formula.
That's one of them. Yes. And if you want it, of course, tangent x over 2, you will take the square root and you'll write plus or minus the square root of 1 minus cosine x over 1 plus cosine x. Before we move on to the last part here with the product to sum formulas and sum to product formulas, I'd like to practice from each and every type of problem here, and then we go back. Okay, on page 514, page 514, I'd like to choose from the first set first, from 3 to 10. Any preference?
Yeah.
Very good. So we are given sine x, 7 on page 514. Sine x equals negative 3 divided by 5. X is in the second quadrant. They're asking us to find sine 2x, cosine 2x, and tangent 2x. I need the formula for sine 2x.
2 sine a cosine.
Yes, 2 sine x, cosine x. I do have this piece. It's given to me already. I have this piece which is negative 3/5. How can sine be in the second quadrant? Oh, it's the third. Yeah. I copied incorrectly, sorry. I just said, okay, how can it be negative? So how can sine be negative in the second quadrant? Made no sense. And then I looked up, it said 3. Of course.
Can you just plug it into the triangle to find cosine?
You could. Or, you know that cosine in the third quadrant is negative.
Where can I go that way?
It's up to you.
I'm a triangle kind of guy.
It's up to you. We will get the same answer. I know cosine in the third quadrant is negative, and I know cosine is the square root with plus or minus, but I already established it's minus. the square root of 1 minus sine squared. And sine squared is 9 over 25. So this is negative the square root of 1 minus 9 over 25. 25 minus 9 is 16. And the square root will be negative 4 over 5. So therefore I know that this piece is negative 4 over 5. Or you think in terms of the triangle. You'll have to get the same answer. So in order to find sine twice x, I have, first of all, these two are negative. So the answer will be positive. 2 times 3 is 6. 6 times 4 is 24. And 5 times 5 is 25. Can this number be more than 1? No, because sine of any angle cannot exceed 1. Very good. Any questions? Is this okay? Okay, now say it again.
Where was the 9 over 25?
25 over 25. Oh, I have to square this.
Oh, okay. So you plug the negative process into sine, and then okay, you solve that. Okay.
Now I'm also asked to determine cosine twice x. Because I'm given sine, I'm not going to bother with cosine. I have a formula that says that 1 minus 2 sine squared. That's why those two are so useful. Yeah, the second and the third. 1 minus 2 sine squared x, which is 1 minus 2. I square sine, and I get 9 over 25. I multiply by 2 over 1, so 1 minus 18 over 25. And then 25 minus 18 is 7. Do we agree so far? Now I want to find tangent to x. I am not going to use the formula because I know tangent to x is sine to x, which I have, over cosine to x, which I have. So the top is 24 over 25. The denominator is 7 over 25. Therefore, the answer is very good. So find cosine, find sine to x, cosine to x, and tangent to x from the given information. Is that clear? Are we in agreement? Yes or no? Yes?
Yeah. I gotta look at
Is this okay?
So for the cosine one,
Yes?
is there a reason why you chose that? Oh, because it's
I was given sine. I could have used the any other, even the other two, because I already, by that time I got to cosine, I had both.
okay. That's it.
It doesn't matter. Everything okay?
I think so.
Okay, next set. Super important. Use the formulas for lowering powers. Yes, I'll have to explain. Lowering powers to rewrite the expression in terms of the first power of cosine. Let's choose a problem. Let's not start with a problem that is power 6 because it will take a while. Let's start with maybe 11 or 12. Which one? Okay, very good. 12 on page 514. So in 12 we are given cosine to the fourth x. What does, allow me to stop, I got to the 50-minute